So, have you ever stopped to think about how an AI decides if you get a job, or a loan, or even something as serious as a medical diagnosis? I mean, this isn't science fiction anymore, right? This is happening right now. And the fairness of those decisions, well, that impacts every single one of us. So to really get this, we've got to dig into what fairness even means when we're talking about AI.
For this explainer, we're pulling all of our information directly from a single, really focused source. We're going to be walking through the key ideas from Chapter 3 of a document called Ethical AI and AI Security, a comprehensive glossary, which was put together by Virtualization Options LLC. This chapter is all about fairness, bias, and how these machines make decisions.
So here's our game plan. We're going to start with why AI fairness actually matters to you personally. Then we'll get into the anatomy of bias, where it really comes from. After that, we'll look at a fascinating piece of this, our own psychology. Then we'll cover how you can actually measure unfairness. And finally, we'll talk about the big quest to open up that AI black box. It's going to be a journey from seeing the problem to searching for the solution.
Okay, let's jump right in. Section 1, AI fairness and you. And this is so important because, look, this isn't some abstract technical thing. We're talking about automated decisions that can literally change the entire course of your life.
Just imagine you're applying for a mortgage. An algorithm is churning through your entire financial life, your job, your history, maybe even where you live, and it spits out a yes or a no. But what if that algorithm is unfair? What if it's got a hidden bias that nobody even meant to put there? This whole loan approval thing is a perfect example, and you'll see we're going to keep coming back to it.
So, that's the big question, isn't it? Where does this unfairness actually come from? And that brings us right to Section 2, the anatomy of bias. Now, the most important thing to get here is that bias in AI isn't always some evil person programming it to be unfair. A lot of the time, it just kind of creeps in silently right through the design process itself.
Our source document has a great term for this, algorithmic bias. And this is a really key distinction. This isn't just about feeding an AI bad, biased data. It's about how the problem is set up in the first place, the choices engineers make about what information to even look at, and what the ultimate goal is. That's where the systematic discrimination can quietly take root.
So how does this bias sneak in? The source breaks it down into 3 really clever ways. First, you've got feature selection. You might tell an AI, hey, don't look at race. But what if you tell it to look at a zip code? And that zip code is a really strong indicator of race. Well, the zip code just becomes a stand-in, a proxy, and you can get the same biased result. Second is label definition. This one's wild. Imagine training an AI to find a good employee using data from a company that, for decades, only promoted men. Well, guess what the AI learns? It learns that good employee equals male. And finally, optimization. An AI can be 95% accurate overall, which sounds amazing, but that accuracy number can hide a big problem. What if it's wrong almost every single time for one specific minority group? That massive failure just gets washed out in the average.
But here's the twist. The problem isn't just the machine. And this, to me, is where things get really fascinating. Let's move on to Section 3, our blind trust in AI. Turns out our own human brains can play a huge part in making this whole situation even worse.
The term for this is automation bias, and it's exactly what it sounds like. It's this weird tendency we have to just believe the computer. Even when our own gut feeling, our own expertise, our own eyes are telling us that something is wrong, we have this habit of deferring to the machine, just assuming it must know better than we do.
And the glossary gives us a pretty chilling real-world example of this. So there's an AI that's built to help radiologists spot tumors, but in one case, it fails. It misses a tumor that's completely obvious. The human radiologist, who's the final check in the process, takes a look at the scan. But because they're so used to trusting the AI's all clear, their brain just glides right over the tumor they would have easily caught otherwise. That's the power of automation bias, and it's pretty scary.
Okay, so if we know this bias can exist in the machine and in us, how do we actually find it? How do we prove it's there? That brings us to Section 4, detecting digital discrimination. Because you can't fix a problem until you can measure it, right? We need a solid mathematical way to see if a system is being unfair.
The main tool we use for this is a concept from law called disparate impact. And what's cool about this is that it doesn't care about intent. It doesn't ask if someone meant to be unfair. It just asks one simple question. Does this system, this policy, whatever it is, create significantly different results for different groups of people? It's all about the outcome.
And to make this practical, there's a really common rule of thumb called the 80% rule, or sometimes the 4/5 rule. The idea is actually pretty straightforward. You find the group that has the highest success rate, and you compare everyone else to them. If any other group's success rate is less than 80% of that top group, then a big red flag goes up. It's a sign that you might have a disparate impact problem.
Let's make this super clear with our loan example. So look at this. Let's say the AI approves loans for 50% of applicants in one group, but for another group the approval rate is only 30%. To check this with the 80% rule, you just do some quick math. You divide the lower number, 30, by the higher number, 50. That gives you 0.6, or 60%. And 60% is way below that 80% line in the sand. That's a textbook case of disparate impact, and it tells you that something is going on and you need to investigate.
So, we found the bias. Now what do we do? Well, that takes us to our final section, opening the AI black box. This part is all about one of the biggest challenges in AI today, the mission to understand why a system made the decision it did.
And this leads us to the huge concept of explainability. Think about it. If that AI denies your loan application, you deserve to know why, right? Was it your debt-to-income ratio, a late payment from 2 years ago? Explainability is what turns a flat no into a reason you can actually understand and maybe even do something about. It is absolutely essential for us to trust these systems and for engineers to be able to fix them when they break.
Now, the source material points out two main ways to achieve this. On one side, you have interpretable models. I like to think of these as glass boxes. They're built to be simple from the start, like a basic flowchart, so you can literally look inside and see the logic. But on the other side, you've got these incredibly powerful, complex models, the black boxes. For those, we have to use special techniques that try to peek inside after the decision is made, to kind of guess or approximate the reasoning. It's an explanation, sure, but it's an educated guess, not the real thing.
And this right here brings us to the biggest dilemma in AI fairness. It's this massive trade-off. Those simple, clear glass box models, they're super easy to understand, but a lot of the time, they just aren't as accurate. And the powerful, complex black box models, they can be amazingly accurate, but their inner workings are a total mystery. So you're stuck choosing between accuracy and clarity, between power and opacity.
So I'm going to leave you with this final question to think about. If it was a decision that could change your life, which would you prefer? An answer that's 99% accurate but comes from a black box that can't tell you why, or an answer that's maybe a little less accurate, say 95%, but is perfectly clear and you know exactly why the decision was made. There's no easy answer here, and that question really is at the very heart of the challenge of building fair and trustworthy AI for all of us.